Hello everyone, welcome back to my YouTube channel Base Your BTech. So after a long time we are back with some questions. This time it is some objective type questions taken from the same topic, the last topic, that is single phase AC system. These are the questions taken from the book Electron. The details of the book is given in the description box. So I plan to discuss in each session 5 questions. Okay, 5 questions per session. So here it comes the first question number 181. It says the maximum value of an alternating current in a circuit is 10 ampere. If an ammeter is connected in the circuit, what will be the reading of ammeter? So it is an alternating current that is given for any alternating quantity which is a sinusoidal waveform. Let be A. This is the maximum value AM and this is the time period T. So this waveform, this sinusoidal representation is like A, which is in the y-axis, is equal to the maximum value AM sine 2 pi by T into T. Okay, where T is the time period. So I can even write it as sine 2 pi 1 by T is frequency T, or it is AM sine omega T. So you can compare the given questions. Many questions will be coming up which uses this representation. So you can study all these 3 representation and do some questions of this sort. Okay. So here it is given the maximum value as 10 ampere. It is a current signal. So IM is equal to 10 ampere. And the question here is, if an ammeter is connected in the circuit, what will be the reading? So ammeter or voltmeter, any instrument will read the RMS value. And the RMS value for a sinusoidal representation, sinusoidal waveform, is the maximum value divided by divided by root 2. Okay. So here it is 10 divided by root 2, which is 10 into 1 by root 2, you know it is 0.707. Okay. So it is 7.07. Coming to the next question, 182. It says an alternating current of frequency 60 Hz has a maximum value of 12 ampere. Find the time taken to reach the maximum value for the first time. So again it is an alternating waveform, which is a sinusoidal one, and the maximum value is 12 ampere and the frequency is 60 Hertz. That is, one wave, time period of one wave is the capital T. So what is the time for the wave to reach its maximum value for the first time? You can see from this graph, it reaches the maximum value 12 ampere for the first time, second time, etc. So for the first time, we need the time value till here. Okay, and it is actually the 1/4 of the capital T. This is actually T by 4 because this complete duration, the complete duration is T, half of it is T by 2. Again, we need the half of T by 2, that is T divided by 4. And I have just said that what is T? T is 1 by F, isn't it? 1 by T is equal to frequency. So T is 1 by F. Again a 4 is there in the denominator. So it is 1 by frequency given here is 60 Hertz. 60 into 4. Now it is 1 by 240. Next part is something crucial in the objective type question. That is how to solve this and arrive at the options given. So it is 1 by 240. You can approximate it like 1 by 250. Okay, and you know that when I multiply numerator and denominator with 4, the denominator easily turns to 1000. That is 25 into 4 is 100. Again add a 0 here. So 4 by 1000 is the answer, which comes about 4 milli. And just the time value, so milliseconds. Okay, now get the answer from the option. It is 4.20 is there and nothing near to 4 is there, right? So 4.2 is the right answer. Question number 183. Voltage is represented by 141.4 sine 377 t. What is the frequency? Again, you can compare it with AM sine 2 pi ft. Okay, so 2 pi f indicates the 377. this 377. So we have to get the f value. All these are very direct questions, very easy questions too. 2 pi f. So what is f? It is 377 by 2 pi is the f value. And how to solve this easily? You know that 2 pi is 6.28 because 3.14 into 2, right? So it is 6.28. 377 by this value. It is actually 377 divided by, let's approximate to 6. And you know that the first digit coming here is 6. Right. So it is actually approximated value 60. Okay. So we have 60 hertz coming here. And next, moving to the question number 184. Sinusoidal alternating voltage has a peak value of 100 volt. What is its RMS value again? Please confirm it is a sinusoidal wave. Then it is Vm divided by root 2. That is 100 by root 2 equal to 0.707 into 100. That is 70.7 volt. See, for each signal you have each RMS value. Like for square wave signal, the RMS value is its maximum itself. Okay, now for a half wave rectified sine wave, which is like this. Here the RMS value is maximum divided by 2. For square wave, that is like this. It is the maximum value itself. It is the RMS value. And again, if it is a triangular wave, like this, then RMS value is maximum divided by root 3. And if it is a sinusoidal wave like this, then the RMS value is maximum divided by root 2. Okay, you can memorize it like here it is Vm, RMS value is Vm, here it is Vm, the maximum value divided by root 4 which is 2, and for triangular it is Vm by root 3, and for sinusoidal it is Vm by root 2. See, there's a pattern now, root 4, root 3, root 2. So please make thorough with this section. And moving on to the next question, the last question for this session. 185. Question number 185. An alternating voltage of 100 sine omega t plus pi by 3 is applied across an impedance Z and the resulting current is 20 sine omega t. The circuit impedance Z. Z is equal to, we know that impedance is equal to voltage divided by current. Okay, so now voltage is given as 100 sine omega t plus pi by 3 and current is given as 20 sine omega t. So since both of these are a sinusoidal representation of its signal, we can compare or we can convert this to polar form because we are having a division operation here. So better to turn it into its polar form, corresponding polar form. Now you can see the maximum value is 100 angle. See, just compare the angle part coming inside this bracket. It is omega t plus pi by 3. Here it is omega t plus 0. Nothing, no phase angle is there. And make sure that both are in sine wave or both are in cosine wave. You should not have sine and a cosine combination. So here it is pi by 3 angle leading because we are having a positive in between. So it is angle pi by 3. It is leading, right? And here it is 20 angle, no angle is there, so it is 0. So just divide it. 100 divided by 20 is 5. Angle pi by 3 divided by angle 0. Angle A divided by angle B is angle A minus B. Or if it is angle A into angle B, it is angle A plus B. So it is 5 angle pi by 3 minus 0 or 5 angle pi by 3. Now pi by 3 is 180 divided by 3 degrees. That is 5 angle 60 degrees is your answer. So I'll be back with the next set of questions. Thank you.